Okay, good evening. Can you hear me? You can, right? Yes, good evening here. And others, you can hear me, right? Yes. Okay, everything okay. Then give me 1 second. I will charging. Okay, now okay. Okay, this is the final day of measurement lesson. Okay, measurement lesson we can complete within today. We have only mass measuring instrument, triple beam balance, electronic balance, and stopwatch. 3 instruments. They are very simple, not like vernier caliper and micrometer, screw gauge. They are very simple parts of the lesson. Up to now, we completed length measuring instrument. Length measuring instrument, you need to know meter ruler. Meter ruler very simple. Using directly, you can get the answer. The value of measurement in millimeter. Okay, the millimeter, the meter ruler, the least count of the meter ruler is 1 millimeter. The minimum measurement is 1 millimeter. Less than 1 millimeter, 0 point millimeters, we cannot measure by meter ruler. Then we discussed about the vernier caliper. The vernier caliper 0.1 millimeter is the least count. I told 1 millimeter divided into 10 parts. Then after divided into 10 parts, one part we can measure. 1 millimeter divided into 10 parts, then one part, 0.1 millimeter is the least count of the vernier caliper, standard vernier caliper. Okay, last week again we discussed 0.01 millimeter is the micrometer screw gauge least count. That means 1 millimeter divided into 100 equal parts. Then one part we can measure by this micrometer screw gauge. Up to that, every parts, their working principles, mechanisms, part and their functions, everything we have discussed and completed in vernier caliper and micrometer screw gauge. Sorry. Okay, this is the final day. Today we are going to discuss a mass measuring instrument. In mass measuring instrument, our main measuring instrument we need to discuss about electronic balance. Okay, electronic balance. Before electronic balance, if we use nowadays this electronic balance, previously before come to the electronic balance, to get smallest measurement, we use another type of special measuring instrument that we called as triple beam balance. Okay, before we go to the lesson, I need to tell you. Okay, now this is our, if you're doing this as first lesson, actual this is not our first lesson. This is our second lesson. The measurement is our second lesson. Measurements for measuring instruments. This is our second lesson. Then our first lesson is area and volume. That's very simple. Area and volume. Area and volume. Area and volume. Our third lesson is trigonometry. That's another maths lesson. Trigonometry. Our fourth lesson is cell structure. Our fourth lesson is cell structure. Our fifth lesson is the force lesson. Forces. Our sixth lesson is the Pythagoras theorem. Pythagoras theorem. Okay, that's the basic lessons on your syllabus. Our syllabus, they are the basic lessons. Okay, now we doing in group number 2 class measurement. With today class we can finish the measurement lesson. Okay, now 27 group 1 class forces also completed. Okay, your class I will take yellow color your class. Then measurements completed. Green color group number 2. We completed 2 lessons. Now they are first mock exam and some 2 to 3 months more than you they have completed. Actually approximate 3 months, because the force is a very long lesson. Force is a long lesson. Forces is not like these measurements. It is a long and bulk lesson. Forces. Therefore, in this time, from next week, in this time, we discuss the force lesson. The force is important because if you take first lesson, our first lesson, it is a maths lesson. Maths. If you go to third lesson, maths lesson. Again, this is biology lesson that we can discuss after all these 5 lessons. We start the biology lesson. The biology is only theory, no calculation. We have only 2 biology lessons, cell structure and biomolecule. We have only 2 biology lessons, no any other biology lessons. Biology lessons we can discuss later because they don't have any calculation. Only you have full note, and I'll explain every theoretical part. Then you can prepare your own short note and remember this is cell structure. They are easy lessons. Okay, but easy, but it has some bulk note. Both bio lessons, it has bulk note because they only theory lessons in our syllabus. Other all lessons are lessons with some part of calculations. Some part of calculations. Okay, I told you in our group number 1 class we have completed measurements and forces both lessons now. In your class we have completed measurements with today class. Then from next week, in group number 1, our common class, we're going to start our basic mathematics. Basic mathematics mean they are the basic mathematics. Trigonometry, area and volume, and Pythagoras theorem. They are basic mathematics. Basic mathematics mean we have another advanced mathematics part also. The advanced mathematics part, we have 2 long lessons. That is statistic and coordinate geometry. Statistics and coordinate geometry, they are very long, bigger lessons dekak. Okay, and with advanced calculation. But in this part, the initial part of the syllabus, they are very basic mathematics, same as your O-level time, that we called as basic mathematics lessons. Basic mathematics lesson. Basic mathematics lessons. Okay, these 3 lessons we start from this Tuesday. Tomorrow Sunday, Monday, Tuesday, after 2 days. Okay, you have to compulsory group number 2 and group number 1 students both compulsory these basic mathematics lessons. Then from next week you have 2 classes per week. 2 classes, Tuesday 6 to 8:30 p.m. Saturday 4:30 to 6:45 p.m. Then after forces completed, after completed forces lesson, we can finish this class. We don't need to again continue this class. That we can keep as bulk day. Sorry, that we can keep as extra day if there are any problem to have. We can take as option. Okay, there is no any after complete measurement then now completed. After complete forces again, no, don't need group 1 and 2 both, like 2 classes. You can join with group 1 class and continue without any delay. Are you okay? the thing is approximately 2 months until now September. I will try to complete forces within 2 months. Within 2 months means you have 8 classes, 16 hours. Until that, you have to come 2 classes per week. Is it okay? 2 classes mean 4.5 hours per week. Then after that, after this end of this Saturday class, you will have exam, the mock exam number 1 that already completed group number 1 students. After this class, you will have this exam, and you will within same day I can give you marks. Then you can continue with group number. After the exam, you can continue with group number 1 students. Okay, any doubt, any problem? You all free Tuesday, I think, I hope. No any ICT or ET class I can discuss. I think no any ICT class, right? Others, only 2 send me messages. Sadev, Ravidu, Vihanga, okay. Okay, good. Then okay, then this Tuesday you have class. I'll send all information into your group also. You don't need to join with group number 1. Then you will confused. I will then they also confused when I send message Saturday classes. You can stay with your group number 2 group, WhatsApp group. Then I will send all your relevant information for you into your groups. I will forward. Then after that, you can join with them group. I will inform. I'll let you know when you need to join with them. Okay, that's our plan. Then within 2 to 3 months, you within next 3 months we can complete up to now, except cell structure lesson. අනිත් ඔක්කොම අපිට කරන්න පුළුවන්. Area and volume, trigonometry, forces, and Pythagoras theorem. Then 5 lessons completed. 5 lessons completed. We have only 20 lessons. Okay. Okay. Measuring instruments. For basic mathematics, you need a notebook. Okay. For maths lessons, you don't have no tute as a note. As a PDF note, you don't have tute. You have only working tute. Working tute means only question bank. You have question book. For this lesson, you don't have. Actually, these math lessons, area and volume, basic mathematics lesson don't have any tute. Only lot of calculations only. Only calculations. Therefore, you need a notebook for Tuesday class. Notebook normal CR book. Okay, that's all about our plan. Come to the lesson. We already discussed measuring instruments. So measuring instrument, the length measuring instruments completed. Length measuring instrument. Now today we have mass measuring instrument. Mass measuring instrument. Mass measuring instrument. Okay. Nowadays, everywhere in supermarkets, banks, not only that, even in very small scale shops in your around your home, they all using electronic balance to measure mass. No, nowadays. But before come to electronic balance, before popular this electronic balance, we use another type of manual balance. manually measuring balance that we get different types of, I think if you know, in large, do you know different types of manual scales like this? What we call this type? What we call this type balance? What we call this type balance? කොහොමද මේවට කියන්නේ? Pan scales, right? It has two pans only. By using moment of force theorem, we can measure. There are different types of, they are manual scales. Manual scales. Yeah, crystal body scales. Yeah, there are different types of manual scales we use. But before come to the electronic balance, to get smallest measurement, is it possible to use this one? Is it possible to use get very smallest measurement like 0.0.01 like gram, like very sensitive small measurement? Is it possible to use this one? No. මේ වගේ එකක් use කරන්න බෑ. It is very difficult. Now to get this type very sensitive measurement, before popular electronic balance, mainly bank and gold shops, රත්තරන් විකුණන වගේ තැන්වල gold shop mainly used triple beam balance. Okay, in our syllabus they have clearly given the triple beam balance. You need to understand what's the meaning of the triple beam balance. The name also given triple beam mean it has three beams. No, it has three beams. It has three beams. It has three beams. It is like this. Normally the triple beam balance like this. It has three beams like this. Three beams. Three beams mean like rods. Three rods like this. Three beams. Okay, let me show with all animations. I will show you. Okay, now these all beams are, all three beams connected as one beam like this. It has connected as one beam like this. It has connected as one beam, and this side there is a arrow mark that we call as indicator. That we call as indicator, and this side is connected with the measuring pan. That is a measuring pan. That is a measuring pan. Now, this is the basic mechanism of the triple beam balance. It has three beams and all beams connected as one structure. Set කරලා තියෙනවා. Then one side of the beam connected arrow mark that we called as indicator. Then other opposite side, it has a plate that we called as measuring pan. Measuring pan. Okay, go to the tute. Go to the tute. I think you all have tutes now. If not available tutes, please send me message. I think if you new students, you can send me message and you can have a printed tute. Other thing, don't need to take print out of this paper. The full printed note I will send you all. I have printed tute. I can send you. Okay, that is the that we called as triple beam balance. It is very simple instrument. Okay, first of all, let's identify the parts of this triple beam balance. Make a parts sanduragamu. Let's identify parts. This one we called as a measuring pan. Measuring pan. This is a measuring pan. That is a measuring pan. Measuring pan. Okay, in your tune, you can note down. I not given here names. I only given only symbols for your understand. Measuring pan. They are the beams. They are beams. I told there are three beams. You can see one, two. Now, okay. Sandeep, now you can hear, right? Yeah, you can't hear. Please let me know quickly. Okay. This is a measuring pan. This is a pan that place object. We take measuring object we place on the measuring pan. They are the beams that we called as three beams, and this arrow mark we called as indicator or pointer. Indicator or pointer. And this point in our animations, you can clearly see there is a zero mark here. There is a zero mark that we call as zero mark. Zero mark that we call as zero mark. Zero mark. Zero mark. Zero mark. Okay, see, they are riders. Riders. What's the meaning of the riders? Riders. Only understand names. I will explain how to use this one. And this one we called as adjustable screw. The B is the adjustable screw. That's a very small screw that we can rotate and adjust this arrow mark. Okay, that we called as adjustable screw. Adjustable screw. Adjustable screw. Adjustable screw. Okay, they are the main parts of the triple beam balance. And this part we called as stage. Stage or base of the base of the instrument. Okay, note down all parts of the triple beam balance. If you complete, let me know. If you complete, send message. Done. Good. Okay. Let's try to understand parts of the triple beam balance. Okay, that's the triple beam balance.
Okay.
This is the triple beam balance. This is the triple beam balance. Okay, that's the measuring pan. That's the measuring pan, and this is a stage. Stage. Measuring pan. Pan කියලා දාන්න. Measuring pan. They are the beams. Three beams. Three beams, and they are riders. Riders, and this is the pointer or indicator. See, this is an arrow. This is an arrow. Pointer. And can you see there is a zero mark here? Okay, this zero mark with line that we call as zero mark. Zero mark. Zero mark. Zero mark. Okay, there, and this is a pan, and there is a screw that we call as adjustable screw. Adjustable screw. Adjustable screw. Okay, they are the main parts of the triple beam balance. You have to remember these parts and their functions. Functions I will explain now. First of all, you need to remember the parts. Okay, can I erase everything? Remember every parts. These parts very important for understand the mechanism. Okay, there is another part. Can you see there is a screw-like part here? What is this? What do you think? Any idea? What is this? What is the purpose of this part? Like a nail, a screw nail? Any idea? No. Okay, that we can discuss the after discuss all functions, that we can discuss what is this called. If you want, you can name, but in given picture it's not clear. You can mark this, that we call as extra bar hold. Extra bar hold. If you want, you can name this part also. It is called as extra bar hold. 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 Okay. Are you okay? Every parts? Measuring pan, riders, three beams and pointer, zero mark, stage, adjustable screw. They are the main part of the triple beam balance. Okay. Now,
this is Mr. Biden. This is a quick tutorial on how to use a triple beam balance. The triple beam balance is one of the most common scientific instruments that we're going to use in science class. We use the triple beam balance to find mass of an object in grams. Today we're going to find the mass of this iron cube. To begin with, let's go over some of the features of the triple beam balance. Here is the pan. You want to make sure that the pan is clean.
okay. This tutorial also explaining full working principle of the triple beam balance. Before that, I will explain and I will give you a chance to watch this. Then you can get the 100% idea how we use and what is the working principle of the triple beam balance. Okay. Now, first of all, I told this three beams has connected as one beam. Beams තුනක් තිබ්බට ඒ තුනම එකට connect කරලා තමයි තියෙන්නේ. It has connected as one beam, and one end of this beam set, it is connected to an arrow. This is an arrow, and other end of the beam connected to a measuring pan, and now it is just like that, like a beam. This This side is a arrow and this side connected to a measuring pan. Okay, when we place any object on this side, what happened to this beam? The descent going up or down? If we place some weight on this side, what happened? Descending going up or down? When we place object on this side, what happened? Sade, what happened? The indicator, think this is the indicator or pointer. It is the indicator going up or down when we place object. Fifty. I need answers. That's a very practical thing only you need to understand, no any theory to discuss. Okay, guys, think this lever set as this pen. When we place object on this side, what happened to the indicator? It's going up or going down? What do you think? The indicator going up. Very good. The indicator going up. The indicator going up. The indicator going up. Okay, it's same as triple beam balance. When we place object, think this is an object. When we place object on the measuring pan, what happened? This indicator going up and come to this level. Indicator ko dayana, point take. Then we have, think this is my object. We have 3 beams and 3 riders here. Okay, understand this riders, very important for this. Understand these riders, very important. Okay, I'll share in my laptop for better resolution. Same.
Find mass of an object in grand balance. Different view. Sure. Then we have this lined up right here with each of these little lines in each sub. And
Okay, now okay. Give me a second. Okay, see this one. Okay, this one, can you say it has 3 beams? These are 1, 2, and 3. Okay, first understand middle beam. This one, middle leg down. It has 0. Can you see my arrow mark? This one, mouse point. Vihanka, Sandeep, make a pen on. Okay. Okay, now go to the middle beam. Middle beam. This middle beam, it has 0. This value, the minimum 0. 100, 200, 100, 200, 300, 400, 500. And if you go to the final beam has 0, 1, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Then if you go to the close, if you come to the closest, the closed one, this one with this finger, it is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And important thing is the middle one and final one, it has grooves. Grooves like holes. Actually, we called as grooves. Grooves. You can cut the wage kapala dena. Okay, then these riders we can shift into this right side and we can put into these grooves. මේවට අපිට insert කරන්න පුළුවන්. That we can insert into these grooves. And this one, the final beam is not like that. It has very small rider. It can slowly move along this into right side, it don't have any groove. Ek grooves nahi. And normally the middle beam rider is, it has calibrated in 100 and 100, 100 by 100, and the mass of the rider also 100. This one calibrated 10 by 10, the rider mass of also 10 gram. And this one also, the mass of the rider is 1 gram. And very important thing is the final beam, it has calibrated 1 by 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It has only 10 gram calibration. And the final important thing is it has every gram, it has divided into 10 equal parts. See, every gram 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, it has 10 equal small parts, small divisions. Therefore, the least count of the triple beam balance. How about the least count? How about the least count of the triple beam balance? The least count, can you see? 1 gram has divided into 10 equal parts. Then 1 gram divided by 10. That is the minimum measurement that we can obtain by triple beam balance. It is 0.1 gram is the minimum measurement that we can obtain by triple beam balance. Okay, I got some idea about 3 beams. Okay, tell me about middle one. The middle one is calibrated 500 to 100 by 100. The maximum value is 500. The final one, it has calibrated 10 by 10. The maximum value is 100. The final one, nearest one, it has calibrated 1 by 1. The final value is 10 gram. And 1 gram divided into 10 equal parts. Therefore, the least count of the triple beam balance is 0.1 gram. Okay, I got up to now. I got up to now. Others, so I got up to now. Any doubt you can ask about triple beam balance, then I can explain. That's a better way learning. Okay, now I'm going to explain the working mechanism of the triple beam balance. I hope now you have all idea about these beams. Okay, others, I got yes. Okay, very good. Then what is the least count of the triple beam balance? 1 divided by 10, it is 0.1 gram. 0.1 gram is the least count, and it has 3 beams as calibrated like this. Okay, now this part is very interesting. Okay, now I am going to measure something by triple beam balance. Okay, now I have whatever object, whatever metal cube. I need to get the mass of this metal cube by using triple beam balance. Think this is my object. I first clean the measuring pan. I place the object on the measuring pan. Think now what happened, as I told, the indicator or pointer going up to this level. Going up to this level. Then by these riders, if we got this indicator again zero mark, that is the basic principle. That's the basic thing you need to do for get measurements. Okay, but these measuring steps very important. Okay, now I have placed the object on measuring pan. Then as I explained, the indicator going up to maximum point. The indicator or pointer going up to maximum point. Now we need to start take measurements by highest mass beam. Remember very well, we need to start highest mass beam. What is the highest mass beam? First one or second one or third one? Highest mass beam, highest mass rider, highest mass rider. Yeah, second, middle one. Good. Second, middle one. Okay, now I am going to start taking measurement. First of all, I am going to place the first rider into first group. First group means 100 group, 100 gram, 100 gram. Okay, think still the position of the indicator, no any problem, same. Therefore, again continue, I put into 200 gram. 200 එකකට දාන්න. Think still same, the pointer is still same. Now when we place into the 300 gram, pointer what happened? Pointer come to lower point. Passing 0 mark, point එක පහළටම එනවා. Then what happened? The meaning, the mass of the object is less than 200, less than 300. Now when we change into 300, if it is come to lower point, that's meaning is the mass of the object is less than the 300. Then again we need to place this rider into previous one. I calling it down. Then again indicator going to upper. The meaning, then we can find from this process, in the first process, we can get the mass of this object, more than 200 gram and less than 300 gram. No? More than 200 and less than 300, that you found in the first attempts, first activity that we can found. Then after that what to do? Then you need to start with second rider, second highest mass rider. The second highest mass rider, first one, second one or third one? Sadev, second highest mass, middle one or third one or first one? Second highest mass rider. Good. Third one is a second highest mass rider. Then same process, put into first group, no any change. Put into second group, no any change. Say third point, no any change. Think when we put into fourth one, indicator again come to down. The meaning, the object higher than the object mass is less than this 240. Then we need to place again in previous one. Again into previous one, then the indicator going up again. Then after that we have very small rider, final one. Slowly move into right side. When it is moving into right side, there is a certain point, the indicator slowly come down and coincide with 0 mark. Then by adding this point, think it is this one, 300, 200, 230, this value 30, and 234.5 like measurement we can get by adding these values, by adding these rider values. Okay, I got any doubt? Sandeep, any doubt? By adding these three values, you can get the measurement of the object. at the coincide point. When the pointer become coincide by the value of the beams, by adding we can get the measurement. Which part, Sandeep? Sandeep, which part you want? Yeah, first of all, place the object on the measuring pan, then the indicator going up. Then we start measuring with highest mass rider, then place into one by one and check until the pointer become down. When it is become down, place the rider previous position. Then after second highest mass rider doing same thing, put into one by one, and when it is going down, place into previous one. Then finally move smallest rider, third one, into right side until the 0 mark coincide with indicator. Then after that, add in these rider values. You can get the measurements. Now, any doubt? Sandeep. Okay, let me others. Ahmed. Others, Sadev, I got. Ayash. Okay, let me show you what are the steps. Clearly understand this. Okay.
Free of any debris or water that might.
Can you hear sound? Video sound? When I play?
Might be on it before we start. If we don't, that could affect our results. We'd be taking the mass of the water or whatever's on there instead of the mass of just our cube.
Yeah, this is object.
These are the arms. We want to make sure that when we start, the weight that's on these arms are all the way down here. It's what we call having it 0. And we also want to make sure that we have this lined up right here with each of these little lines on each side matching. They're lined up. Now, we also want to note that there are little grooves on these two arms.
Grooves.
Where the weight fits into. We want to make sure when we move these weights back and forth.
If there are no any object, it's going down. And it is going up and down. The indicator.
Right results. So let's take the mass of this iron cube. We'll put it on here. You know it's right away. This anyway.
It's going up.
Right up to the top. We're going to start with the heaviest mass and move this over.
Heaviest mass.
Can you go down?
No,
So we have to go one more. That time it went down.
You take
now
into
we're
previous
back. We're going to go to the next headings. This one in the rear. Move it up. Move it up. Move it up. There we go.
Then again.
Now we're going to move that. Finally, we're going to go to the lightest one, the smallest little mass here. We're going to move that across. Just tap it with your finger. Tap, tap, tappity, tap, tap.
See, indicate.
Tap, 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 tap. There we go. Right, that's lined up pretty good. All right. And we want to try to be as accurate as we can with the triple beam balance. It can be difficult, but get it onto one of these lines that you see on that front bar. Now, how do we know what the mass is? What do we do with these numbers that they're lying on? Well, let's go ahead and take a closer look to see what we really need to do in order to find out mass of this cube is. Okay. Right? What do we do with find out what the mass of this cube is? Find out what the mass of this cube is.
Okay, let's try to get this value. Now this value is 100. The middle one 100. This one 20. We cannot get because of the coverage. Cover by this one. Okay, this one is not 6. You can see there is a small arrow. We need to get the point value according to this arrow. See, I'll let you.
Let's look at the largest one first. 100.
100.
So that's 100.
20.
When? 120.
See this one.
What does this one say? Well, it's right after the 5.
See this? There is a small arrow part. No, this is an arrow. We need to get. It is not 6. We need to get the value of this arrow. I mean this arrow. 5, 5.5, 6, 7, 8, 9. 5.9 milligram is the value. Then we can get the final value. How we get? I told all values coming from all 3 beams. You need to add. Then 100, 20, and this one 5.9, right? Then 0.9, 125.9 grams is the value, no?
Before the 6. So that's going to be 125. How many lines over it is? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 125.9. 125.9. Now, what are the units for mass? Grams. So we'd want to report this as 125.9 grams. Now that's the basics on how to use a triple beam balance. Make sure you practice a lot so you know how to use it.
Okay, any doubt up to now? Any doubt? Guys? Everything clear? Working principle and others? Ahmed? Good. Okay, now before go to the tute, can you send me what is the maximum weight, what is the maximum mass that we can measure by this triple beam balance? What is the maximum value? What do you think? What's the maximum value? What's the maximum value? What is the maximum measurement that we can measure by this? Yeah, minimum measurement. Now we got the minimum measurement. That is a least count. It is 0.1 gram. How about the maximum measurement? Very good, Vihan. It is 610. Why? The middle beam 500 maximum, final beam 100, the nearest one 10. 500 plus 100, 600, 610. The maximum mass 610 gram. 610 gram is the maximum mass. But this range is enough. 0.1 and 610 gram is enough for get measurements. No, think I have object, its weight 1200, like 1 kilogram and 200. Then how we measure this? The supplier of the manufacturing instrument, manufacturing agency or company, they will provide, with this instrument, they will provide 2 or 3 extra bars. Extra bars තුනක් දෙනවා. They are 100. It just like this extra bars, like this. The one is 1 kilogram. 1 kilogram. The other one is 500 gram and next one 500 gram. Okay, they are the extra bars. Then think I want to get more than 1 kilogram measurements. I need to get more than 1 kilogram measurement. Then I can get, it has some mechanism to connect to this screw. Then we can connect this 1 kilogram into this point. Then we can do the measurement process as same as usual measurement process as we discussed now. Okay, if you want think you want to get now when we connect this 1 kilogram, the maximum mass is 1610 gram. Then if I want 2 kilogram like measurements, 2 kilogram like measurements, then we can connect both 150 additionally and 610 available, already available, then we can add 150. If we need more than 2500 like measurement, we can use all these extra beams, extra bars, then we can connect it to this place and get the measurement as usual methods. Now, with these extra bars, how about the maximum measurement? With this all extra bars? Now what? Now how about the maximum measurement? The minimum measurements, if it is, if we connect extra bars, the minimum measurement, no any difference. Meaning it is not affected the minimum measurements. How about the maximum measurements? Sadev and Ravindu? The maximum measurements? Very good. Yes, Ravi. It is now 1 kilogram 500 mean 2 kilogram. After that 2610 gram is 2 kilogram and 610 grams is the maximum measurements. Then with this extra beams, you can get up to 2 kilogram and 600 grams, 610 grams. Okay. Can you hear this? Can you see clear this value? The instrument also given maximum value 2610. Can you see this? Yeah, it is visible, no? The value 2610 is the maximum value. Okay, the 2610 is the maximum value of with this extra beams. Without any extra beam, the value is 610. The minimum value without or with extra beam, it is 0.1 gram is the least count of the instrument. Okay, that's all about triple beam balance. Let's move into tute. Okay, now you all understood the parts and their working principle. The smallest measurement is 0.1. It is given in the tute also. The minimum, yeah, the maximum value 306 without any extra beam. But 2 kilogram load, 500, 200 load and 500 gauge, 2 kilogram load and 500 hang on the end of lever arm, that is can weight up to 2610. This is the maximum weight with this extra beams. The instrument is also provided with clamp support, relatively high take reading with upward upthrust can measured. Instead of placing the load on the disc, it can be string from corner below. Yeah, that's not compulsory. That's our next practical is given that we can discuss later. Okay, this is a simple triple beam balance is given with Friday positions. With rider positions. Can you get this value? That is the rider positions on each beam. $500 scale and 10 gram scale, 100 gram scale, every scale positions given. Okay, highest value, the first one 400, next one 40, next one 4. What is the measurement of this beaker? What's the weight? What's the mass? Get read the mass and send me as a chat. Only 2. Others? Others? You send you message, send you an answer. Okay, good. The value 444, right? 444 gram. Yes, all are correct. 444 gram. Yes. Okay. Now, okay, go to this page. It is given the zero error of the triple beam balance. Okay, what is the meaning of the zero error that we already discussed for all instruments? No, vernier caliper, triple beam balance, for every instruments we discussed the zero error. Zero error means without taking any measurements. That's the initial position of the instrument. If it is without showing zero, if it showing another value, zero එක නැතුව වෙන value එකක් පෙන්නනවා. As we discussed in the first day I told you in zero error discussion, when we go into a shop, before we purchase something, if the instrument, the scale showing some value, that is a zero error. Okay, what is a zero error of the triple beam balance? Triple beam balance zero error mean, think there is no any object on the measuring pan. Then if this pointer not coincide with the zero, that we called as a zero error of the triple beam balance. See,
Yes. Oh,
okay, now this instrument don't have any zero error. There the zero and pointer perfect coincide. There is no any object on the measuring pan. But in this, there any no object with on the measuring pan? If it is showing some, if it is not coincide like this, that we called as a zero error of the triple beam balance. Okay, now what we can do for that? What we can do for that? Do we need to calculate the zero error and add or subtract as vernier caliper and micrometer screw gauge? No, you don't need like this for triple beam balance. එහෙම කරන්න ඕනේ. Do you remember I told there is a screw, I told there is a screw as adjustable screw. Adjustable screw. This adjustable screw that we can use to remove this zero errors. Okay, now if there are anything, now the zero is here, the zero is here, the pointer is like this. Now it has a zero error. Now it has zero error, not coincide. Now what we can do, we can slowly rotate this adjustable screw. Then this lever we can change. We can change the position of this lever. Then we can change the, we can remove zero error, slowly adjust by adjustable screw. Then we can take as parallel coincide this zero mark and point. Okay, therefore in triple beam balance, don't need calculate the zero error. If there are any zero error, the zero error mean there is no, if there are without any object on measuring pan, it is not coincide well, pointer and zero mark, then we can slowly adjust the adjustable screw and get into zero. I get, no need calculate the zero error and add or subtract, don't need, we can adjust into zero. Understood? Sadev? No need to calculate the zero error. We can adjust if there are any error, we can adjust and use as accurate instrument. Okay, it is given here. You can read. You can read. It is given. Okay, now you have to obtain a measurement from triple beam balance. Okay, go to this page number 13. Page number 13, write down first point. Write down first point. Write down first point. Write down first point. Clean the measuring pan. Clean the measuring pan and place the measuring object. Place the measuring object on the measuring pan. Place the measuring object on the measuring pan. Second point. Second point. Start taking measurements. Start taking measurements with highest mass. With highest mass. Highest mass. Start taking measurements with highest mass. Right. Within bracket 100 gram. Within bracket 100 gram. And close bracket and put into each grooves. Put into each grooves. Each grooves on the middle beam. Middle beam. Middle beam. Until pointer. Until pointer come to downward. Come to downward. Come to downward. Third point. When the pointer come to downward. Come to downward. The rider put again into previous groove. Fourth point. Continue the same process. Continue the same process. Continue the same process. Continue the same process for Continue the same process for second highest mass rider, second highest mass rider within bracket 10 gram as well. Second highest mass rider as well. Continue the same process for second highest mass rider as well. Continue the same process for second highest mass rider, that's mean 10 gram rider as well. Final point. Finally, slowly one gram rider into right side until into right side until into right side all right into right side until pointer coincide with zero mark. Okay, final point. Get the reading of the measurement, reading of the mass by adding all rider measurements, by adding all rider measurements. Okay, if any part missing, please let me know. That's a full answer. If exam asks this type, what are the working measuring principle of the measuring process of the triple beam balance, you should have idea to write down with this few steps, within few steps. Get the reading of the mass by adding all rider values. Okay, if you complete, send me message. Complete writing. Vihanga, Sadev, Sandeep. Okay, in exam, no need my words. In your word, you can write your answer, but you should have idea. Okay, others, Sadev, Ravidu, are you complete? Complete your writing, right? Yes. Good. Okay, now we can go to the electronic balance. I told before popular this electronic balance, we use this triple beam balance. Nowadays, no use triple beam balance everywhere in supermarkets, small scale businesses, and banks. We use triple beam balance. Sorry, electronic balance. Okay, that's the electronic balance. The electronic balance, the most important thing is it don't have zero error. If it is zero error means without any object on the measuring pan, without any object, if it is not showing zero measurement, that we called as zero error. Now zero error, very simply you can understand this one. Okay, but this instrument, they contain a zero button. This is on off button and there is a zero button. See, zero button. By pressing this zero button, that we can get into zero. Then we, without any zero error, we can take measurements. And this electronic balance, we can't say exactly what is the least count according to the usage of the electronic balance. There are a range of electronic balance nowadays everywhere using electronic balance with range of least count. Sometimes it's the least count is some instrument 0.01 gram, sometimes 0.001 gram. It depends on the purpose. If you're going to measure very smallest measurements, that we can select electronic balance with smallest least count with higher sensitivity, like in bank, like to measure golds, we use this type electronic balance, highly sensitive one, highly sensitive with low least count, very low least count. But in like supermarket too, we can use 0.1 gram like least count. Now see this given one 0.000 mean its least count is 0.001. 1 gram divided into 1000. Then 1 gram we can, one part we can measure 0.001. See, therefore the range of electronic balance, a wide range of electronic balance used nowadays. Therefore we can't say that exact least count value for electronic balance. The other important thing is the zero. Without any zero error, by within one press, we can remove zero error again. We can get accurate measurement by this electronic balance. Okay, I have given full note. Yeah, this point is important. The different types of electronic scale can be measured very smallest measurements as well as larger mass measurements. Okay, do you have seen analytical balance? Do you have heard analytical balance? Let me show it. Okay, you can send me. Do you have seen? No, let me show you. Okay, they are the analytical balance. Sometimes your chemistry lab, if you visit your school chemistry, or and sometimes some banks also and gold shops, golds measure run this type analytical balance we use. Okay, this type one. Okay, can you see this analytical balance? The measuring plate has covered by glass structure. What is the purpose of that? See this? It's covered with glass. See? You can see this, right? Yes. Why it is covered? Why it has covered? What's the purpose? What do you think? Why it is covered? Normally this is the analytical balance. It has a measuring pan same as normal electronic balance, and this measuring pan has covered by glass cover. What's the purpose? I have Bahalati. Normally in your laboratory, I think it available this type analytical balance. Why it is that covered? What's the purpose? Anyone? You can suggest. You can suggest any reason why it is covered. What do you think? No idea? Vihinga, why you think? What do you think? What can be the reason? Why it is covered? Okay, if you want, I'll show you. Oh, wait. Okay, let me show you how to get. Okay, see this? How we use analytical balance?
One of the most commonly used pieces of equipment in biotech laboratories is called an analytical balance. We can use it to take very precise measurements, 4 places to the right of the decimal point. Keep in mind that a small paperclip weighs about 1 gram. In other words, the analytical balance isn't designed for weighing heavy items. For example, this balance has a maximum weight of 310 grams. That's about the same weight as a can of tomato soup. Weighing anything larger than that will cause damage. The first consideration is selecting the workspace. The balance needs to be placed on a steady surface, such as a marble counter or a lab workbench, in order to minimize vibrations. The balance shouldn't be used near doorways or air vents because it's sensitive enough to be affected by air currents. Check to see if the balance is level. Adjust the feet until the air bubble is inside the black ring. If the balance has been unplugged or turned off, you need to let it warm up and reach the required operating temperature. Let's try an example. We want to measure out 1.5 grams of sodium bicarbonate. Typically, we use weighing paper for measuring anything less than 5 grams. Fold the opposite corners of the weighing paper together and make a crease. Then do the same for the other corners. Place the paper on the balance pan. Close the side doors and press the tear button.
See, open the door slowly, then place the whatever cover that we need to measure. Then again close the door. See this? Again close the door for take measurements. Now I think you have idea what's the reason.
To zero out the paper. Use a lab scoop
This is a chemical.
slowly add the sodium bicarbonate to the paper. Close the glass doors and wait for the balance to lock in its reading. Continue adding sodium bicarbonate until you reach 1.5 grams. Close the doors to the actual weight. 1.5026 grams. And always document your work in your lab notebook. Let's do another example. This time, we'll weigh something a little heavier, so we'll use a weigh boat instead of paper. Let's measure out 12.19 grams of powdered crisp-cover. Place the weigh boat on the balance pan. Close the side doors and press the tare key. We're aiming for 12.19 grams, so the measurement should be within plus or minus 0.02 grams. Always document your work in your lab notebook. Cleaning the balance is an important step, especially at the end of the day. Put it into standby mode or unplug it. Remove the weigh pan and components by lifting straight up. Use a very soft bristle paintbrush to sweep off any powder remaining inside the weigh chamber and in the grooves with glass doors. Once it's clean, replace the drip ring and the weigh pan. Now you're ready to head into the lab and practice using an analytical balance hands-on. To find a life science course.
Okay. Do you have now? I think you have idea why it is covered with a door with a glass cover. Now, the reason is what? The reason is the analytical balance least count is very low value. The least count is very low value. The least count very low mean its sensitivity is very high. If you keep without this cover, if you want, we can open this by removing this cover. When we place in our normal environment, due to the wind vary, the value is changing. Okay, value change, due to even in the fan, the value is changing. That much sensitive. Therefore, internal environment effect that can affect on that sensitive measurements. That's why it is fully covered environment measure, very small measurement to avoid environment effect. I got? Okay, that I want to say you this much of very sensitive instruments, this much of very sensitive analytical balance like electronic balance, that's also an electronic balance. This type electronic balance also nowadays we use in different industries. Understood? That is very sensitive, that's why it's covered. Actually the air flowing is the problem. With changing air flowing in the room, the value is changing. That much of sensitive this instrument. Therefore, see, it has 4 decimal point. 4 decimal point mean 0.0001 gram is the least count. Understood, guys? Guys, send me. I got quickly. Good. Okay, analytical balance. Okay, analytical balance. You don't need to remember. That's also a type of electronic balance. Do you have seen bridge scale? Bridge. Can palam. Bridge scale. Palam tarad. Bridge scale. Do you have seen? දැකලා තියෙනවද? Yes or no? No. Yes. Anyone? Sandeep, do you have seen? Bridge scale. No, the bridge scale, it's just like a bridge. That's also electronic balance, same as bridge. Let me show you. It also a electronic balance that normally we bridge scale. Okay, this is a bridge scale. Okay, I think you have seen that we can normally use for measure containers and large lorries. Okay, it's just same as a see, it's same as a bridge, where and it has a digital screen. When the vehicle come to this bridge, the digital screen given the weight of the not weight, the mass of the vehicle. The mass of the vehicle given display in the digital screen. Okay, that we call as bridge scale. Do you have idea why we use this type bridge scales? Normally large scale industries, normally we can't measure every time the amount of loading and unloading. Very difficult to measure, no? Every time loading karaddi, when we loading, think textile like garment clothes, when we loading every time measure and loading, it is difficult. But we can use this type, think it is the container. Think this is a bridge scale, and this side, this is the gate of the industry. Now think this is the gate. This is the bridge scale. Then when enter vehicles into the industry, measure the weight, measure the mass of the vehicle, empty vehicle with driver and other everything, measure the mass of the vehicle. Then after that, it's entered to the industry and loading whatever good is loading into the container. Then again, it's coming back, measure the mass of the vehicle. Then by difference, we can identify, I think the empty vehicle is 50,000 kilogram. 50,000 kilogram. I think 5,000 kilogram for only understand. 5,000 kilogram. With loading, it is 12,000 kilogram. Then we can get the difference and how much of, then we can say 7 tons. 7 tons has gone out from the industry. Ton hatak eliyata gihin tiyenawa kiyala, then we can keep records, no? We can maintain records very well, easily by this bridge scale. That's much of. Now you can understand the analytical balance, very small, very sensitive instruments. But the bridge scale, large scale measurements that we can get by analytical balance. Sorry, bridge scales. Now I got some idea that much of range of analytical, electronic balance used in nowadays. I got that much of range of electronic balance used nowadays in different industries. Okay, any problem up to now? Any doubt? No. Okay. Now go to the table. Okay, note down here. Very small measurement. Very small measurement. Very small measurements. Analytical balance, example. Analytical balance. Now you already know analytical balance. Very sensitive. Analytical balance. Very sensitive. Very large measurement. very large measurements. Examples, bridge scale, bridge scale, bridge scale, bridge scale. Okay. Okay. We come to the final instrument of this lesson, time measuring instrument. We completed length measuring instrument and mass measuring instrument. Now we come to time measuring instrument. Okay, time measuring instrument, as look in these two types, you know this is an analog type stopwatch. This is digital type stopwatch. The main difference is least count. The least count is the main difference, and accuracy and sensitivity. This one, it is manual type. It is digital with digital screen. Okay, and I will show you our every smart device. Our every smart device now, it has a stopwatch like this stopwatch. Now even in your phone there is a stopwatch. The most important thing, this digital stopwatch that we can use for lap measurements. Time lapse mean whatever time period, no? Whatever time period also we can measure in your digital stopwatch. See, this my smart board has one lap stopwatch, but if you go to your phone, you can try with your phone. The stopwatch has got the stopwatch. This stopwatch. See, we can start. Okay, we can start this. Then we can take laps here. Lap. There is a lap button. Then we can get any number of lap here. Lap mean time period that we can measure separately. Okay, normally time measurements, this digital screen, nowadays we use in digital stopwatch. This digital stopwatch, that is the main advantage, and easily we can reset and stop and reset button here. Easily we can reset, and okay, that's mainly. And in digital stopwatch, the least count is very low and its sensitivity is very high. The sensitivity high. Okay, that's only. And in digital stopwatch, to zeroing button, that's a zeroing button, reset button normally. And analog stopwatch, therefore no need to consider about zero error. But analog stopwatch, there is a screw again convert into zero. Nowadays this analog type stopwatch, now we're not going to use. Always we use a smart device available, smart digital watch, digital stopwatch, that we use to take time measurements, time interval measurements. Okay, that's all about measuring instrument. You can, if you have any missing part, you can go through our website and you can cover. After your this month's payments, class fee, you can request our September course page. Then I will approve this with checking your order number. Then I will approve this. Then you will have every learning materials, every recordings in the course page. You can click green button, enroll course page. Then you can available last month from July, August, September, everything separately given in the website. Okay, you can order. And next week we discuss the tutorial discussion of measurement lesson. I will send within tomorrow. I will send you a tutorial paper. You can try this paper and ready for the discussion. Ready for the tutorial discussion. After that, from next week, after next week, we start the forces lesson, and this coming Tuesday we start the area and volume basic mathematics lessons. For basic mathematics, you don't need any additional knowledge. We starting from very basic level. Actually, I hope to start in grade 6 level. Okay, therefore don't need to worry. Everything I will refresh again. Every grade 6 to 11 again I will refresh every calculation. Therefore don't need to worry. You can join with Tuesday class. No any basic knowledge required. Okay. Okay. Any doubt? Any doubt? Okay, you can go through, and I will send you the tutorial. You can try. If you have any missing part, you can go through with the website. Okay. If anyone don't have access, send me message. I will give you access. Don't we need the last page? Yeah, this need. Sadhu. So I paid for September months. Okay, I think you have paid to pay here, right? By card payment. Yeah, if you pay here, I don't need to accept this. It automatically you will have access now. You can check with green button. You will have access. I don't need to check. I don't need to accept this. Only direct bank payment only I need to accept. Okay, you can check. If any problem, let me know. Don't we need the last page of the tut? Errors while taking. Yeah, that need. Why not? Okay, today our target was instrument, complete the instrument part. Before we start the tutorial class, I will discuss this final part. It is 10 to 15 minute small part that we can discuss next. Any other problem? Yeah, final lesson. This part we need to discuss. That's important. Up to this, only final page we have to discuss. Other whole part up to 15 page, you can go through and complete the tutorial. Okay, any other doubt? What else? Okay, no doubts. Okay, then let's meet again Tuesday. I will send all information into your group. Let's meet Tuesday 6 p.m. Okay, goodbye. If you have any problem, send me WhatsApp message.